page 105 in your math workbook. So make sure you go there before moving on through the video. So today we're going to look at how to use area models and the distributive property. Now we did figure out that distributive property means when you take a larger number and you break it down into numbers that are easier to mentally solve the problem. So we're going to be continuing to use the distributive property, but we're just going to throw in the area model to kind of help us with these problems today. So a school scramble band gets into formation for a parade. There are 9 rows of 18 band members. How can you make a visual model to draw the number of band members that are in the scramble band? Draw a quick picture to show your work. So I circled quick picture because I just want to remind you that quick pictures are exactly that. We don't want to spend a lot of time drawing out these base 10 blocks. So to do that, we are going to go back and look at our problems, and we know we have 9 rows, and in each row there's 18 band members. And the first thing I'm going to do is show 18 with base 10 blocks. So we need one group of 10, and remember the other day we talked about instead of writing our 10s standing up, we're going to start writing them laying down just for this activity. So we have a group of 10, and then we need 8 ones. So we're going to draw 8 ones. 2, 3, 4, 5, 6, 7, and 8. So now we're showing 18 band members. But there are 9 rows of them, so we have to draw 9 rows. So the thing that I would do to help me remember that is I'm going to draw 9 groups of 10. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I've lined that up, have all my 10s together. Now I'm going to come through and I'm going to draw 8 ones 9 times. And you're just going to continue that process all the way down your paper. So you're going to continue. What we're starting to notice here is we have something that looks kind of like an array. So we're lining up our 10s and our 1s, and we have an object that kind of looks like an array. An array has equal groups and equal parts. Well, what would our equation look like? We always want to think about what would the equation look like. So we know we have 9 rows, and in each row we have 18 band members. And Miss Jennifer's made a mistake, so let me fix that. You know me in class, you know that I have no problem admitting if I make a mistake. So, then 9 rows and 18 members in each row. And then we're going to use n for the unknown number. So, we've got to figure out how many band members we have. So, you continue to draw your array, and as you do that, you're going to find that you have 162 band members in the scramble band. So thinking about this and looking at the term talk at the bottom, why is this a good visual model for the problem? Well, if you think about it, we know place value. We've been learning place value for several years now. So using this place value model helps us to find the answer. It breaks down the problem so that we can easily get the answer. To make sure you have this completed, we're going to move on to page 106. So go to page 106, and we're going to continue with this lesson. So let's look at build understanding. Willow is working through some math homework. She comes to 7 times 13 equals an unknown number. How can she use an area model to help her find the product? So let's look at A. How can you draw a rectangle on the grid to show 7 times 13? So we use a rectangle to tell us the area. Now, if you remember back in Module 3, I think it was, we used the very last lesson, we talked about finding the area of a rectangle and using that to help us multiply. So we're going back to that lesson that we've done before. So how can we draw a rectangle? Let's start with 7 squares down. And I'm going to say 13 squares across. So 7 squares down and 13 squares across. Now they want us to actually draw that out. So we're going to draw and label the rectangle as a combination here, there's that vocabulary, of 2 smaller rectangles. So we're going to combine the size of 2 smaller rectangles to show 7 times 3. Something I want to point out here is in our model, you see it says think of a sum for 13. If you remember, sum is when we're adding. It's the answer we find when we're adding. So think of 2 numbers that would equal 13. The first thing that pops into my head is 6 plus 7. So we're going to use that, 6 plus 7. So I'm going to draw a line in my grid. Let's start it right here. And I'm going to go over 6 faces. So 1, 2, 3, 4, 5, 6. Now I'm going to write a 6 up top, okay? Then I said my other add-in that added to 6 equals 13 is 7. So I'm going to continue 7 more squares over. 1, 2, 3, 4, 5, 6, 7. And I'm going to put a 7. I know that 6 plus 7 equals 13. Now, we said earlier, so that's our 13 squares going across. Now we need to draw 7 squares going down. So same thing. 1, 2, 3, 4, 5, 6, 7. So 7 squares going down. Now I'm going to complete my rectangle. Now if we go back to our instructions, they want us to combine 2. So now in my picture, in my model, I need to show 2 smaller rectangles. So I'm going to go back, and where I made my group of 6, or I counted 6 over, I'm going to say 1, 2, 3, 4, 5, 6. And I'm going to draw a line down the middle to separate those 2. So we have a rectangle that shows the area of 7 and 6, and 7 and 7. Now, we're using that model to help us fill out the multiplication and addition equation over to the right side. So let's look at this. First, we're going to say 7 times 6. 7 times 6 equals 42. All right, now we're going to say 7 times 7. So 7 times 7 is 49. Now we're going to take our 2 products that we have, 42 and 49, and we're going to add those together. So 42 plus 49. Now if you get to this and you need to rewrite it, you can. You can come over to the side and you can say, for some of you it might be easier to add vertically. 2 plus 9 is 11. 1 plus 4 is 5. 5 plus 4 is 9. So our answer is 91, which tells me that 7 times 3 also equals 91. So this is how we use the area model to think of multiplication. Now, we want you to make sure, because I've got to move down and it's going to delete my answers. So if you haven't had a chance, I want you to make sure you have this complete. And then we're going to move down to B. So you can pause the video and make sure you have your answers. All right, I'm going to go back and put my equations in just because I want to make sure we use those for part B. Give me just a second. I'm going to complete those again. Just because I want to use this information to help me answer B. How can you use the distributive property and the area model to make multiplying easier? So, we can think of it like this. We can think of 13 as 6 plus 7. So 13 equals 6 plus 7. And then you can use the area model to show that 7 times whatever 6 plus 7 is. Okay, so whatever 6 plus 7. Another way to look at that with the distributive model is the same thing that we did right here in these two problems. We said that 7 times 6 is plus 7 times 7. So that's what we did here. We came up with 42 and 49 to give us 91. So 7 times 3 is 91. All right, how can we find the product? Look at C. How can you find the product? So to find the product, we can write an equation. And find the product of each smaller rectangle. So all I'm doing here is really describing what I just did in the top with the equation. So we write an equation and find the product of each smaller rectangles, and then find the sum of the products. I'm running out of space to write my words. Find the sum of the products. So write an equation and find the product. So that's what we did in the first two steps. Then, once you have those products, you take the products and you find the sum of both of them. So that's just the word form explaining how we solve those problems up in the model. Okay, now we're going to move on and we're going to continue to keep practicing. So let's go to page 107. Page 107. The next problem on Willow's homework sheet is 3 times 9 equals unknown number. How can you use base 10 blocks to show 3 times 19? Draw a quick picture to show your work. So again, drawing that quick picture. So let's start. We know we're going to have 3 rows, and in each row we're going to have a group of 10 and 9 ones. So let's start with our first row. So here's a group of 10 and 9 ones. And we're going to do this 3 times. Okay? How can you use the distributive property to break apart the base 10 blocks and find the product? Well, first I can circle the 10s. Okay, circle the 10s, and then I can circle the 1s. So let's circle the 10s, circle the 1s to find each of these products. So first let's look at our 10s. We have 3 groups of 10s. The value of 3 groups of 10s is 30. Then we have 9 ones, and we have 3 of those, and we know that that's 27. Okay, so now let's look at B. So how can you use the distributive property? We just said we can circle the 10s and the 1s. So we'll write that down. Now let's look at B. Draw a circle around the 10s and a circle around the 1s, which we've already done, and write the numbers to solve. Alright, so we have 3 groups, and in each group we have 1 10. Plus, we have 3 groups of 1s, and in each group we have 9 1s. So now, let's continue. We bring down the 3, and 110, what's the value of 110? That's 10. Then we bring down our 3 again, that we're multiplying by, and the value of 9 ones is 9. So now we continue multiplying. We know that 3 times 10 is 30, and 3 times 9 is 27. So then we add 30 plus 27, and we get 57. So our product for 3 times 19 is 57. This, boys and girls, is the distributive property. This is the distributive property. You may even want to circle this just for reference later, and you can put over to the side distributive property. This is what it looks like. You're taking these numbers, you're starting with a model, a picture, and you're taking these numbers and you're breaking them down into something that you can multiply and you can add. So with distributive property,